Good morning, good afternoon, wherever you may be in your day. As always, thank you for choosing to make chemistry part of your day. And as promised in the last video, we are now going to use that idea of the mole, triple equality, however you want to put it, in action. So here we go. All right, so the most basic calculation is going moles to grams or grams to moles. We will do this more than any other calculation in this entire course. And if you cannot do this, I'm not sure you can pass the class. The good news is it's not that bad. Let me walk you through it. So, for example, convert 0.107 moles of water to grams. Again, this is like a dozen. It's a big number. We don't really need to know what it is. But I do want you to know that's a unit of what? It's a unit of amount. Sometimes we forget that. Grams, hopefully, you know, is a unit of mass. So our conversion factor between amount and mass is going to be what I like to call the formula weight. Other people call it the molar mass. It's the same. We have a lot of M's in chemistry. Little m for mole, big M for molarity, molality. So I try not to use one more M, so I use formula weight here. To each their own. It's a little bit more formal to use molar mass and use an M, but I like the formula weight. I find it less confusing. Okay, that out of the way. So, you know how I like to lay this out. Put the train tracks down, what we're looking for at the end on top, mass of water, so this is a mass, and it's water. So what other information do we have that's either masses or ideally masses about water? Well, we have water and we have amount, so that's loosely related to it, and it's the only number we're given. So we start with that, and we put that on top. Since our amount here at the end is on top, the mass is loosely, the amount here on top is loosely related to the mass on top here. And then we always know whatever the units on top is here. To cancel it out, we're going to have those units down here. Now my question is, do we have a direct relationship between moles and grams? Or from amount to mass? Yes, the answer is yes. It's our formula weight. We can use that. So I'm just going to put grams of water up here. And it's always a bunch of grams per 1 mole. So you've pretty much done the problem. All we have to do is calculate the formula weight. We go to our old friend, the periodic table. Realizing that water is made out of 2 hydrogens and an oxygen. And we get 18.02 grams of water per mole. Double check that they cancel out, that we have what we want at the end. These are all good things to do. Multiply through, and we get, as I always like to say, a number, which I thought I wrote down. Yep, 1.93 grams of water. Does that answer make sense? Every molecule weighs at least more than 1 gram per mole, so our number went up. That makes sense. A couple grams of water, relatively mild amount of moles. So it'll take a while to get comfortable with it, but yeah, that makes sense. All right, moving along. Let's take it a little bit further. Convert 4.82 milligrams of carbon dioxide to molecules of carbon dioxide. So let's do the same logic. Let's build our railroad, put our only number we are given here on top to start with, and put what we're looking for at the end. So that's our basic framework of solving a word problem, even a simple one like this. We know that whatever's up here is going to be down here. And, milligrams is a unit of mass. Molecules is just a count, so that's a type of amount. So we go back to my question of, do we have a and they're both CO2, but do we have a direct relationship between mass and amount and mass? The answer is yes. It's still the formula weight. So we need to get the formula weight for carbon dioxide. So 1 mole of carbon dioxide will be 44.01 grams of carbon dioxide. So this is 1 carbon at 12.01 plus 2 oxygens at 16.00. Now, remember that triple equality. These are the 2 we usually use, but we want actual numbers here, molecules. So we can actually go a step further and say that this is what? 6.02 times 10 to the 23rd molecules of CO2. And this is good. This gives me my molecules, and it relates it to a mass, which is grams. Now, I don't have grams, I have milligrams. Do we have a direct relationship between milligrams and grams? I hope so. That's the metric system. So 1,000 milligrams is 1 gram. We now have grams of CO2. grams of molecules, so I have grams here. I want to cancel that out, so I'm going to put it on the bottom. Molecules on top, so that's the one I'm going to choose out of my equality. And we can just skip the mole part. If you want to use that as a bridge and do two separate calculations, that's fine. And we can calculate that through. And if we do this, it's molecules, it's individual molecules. This should be a huge number. So you might just read off your calculator 6.60. This should ring alarm bells. Whoa, that's way too small. It's got to be more than 6 molecules. Don't forget to look at the end of the calculator, where all the zeros are. And our correct answer, and that does make sense, because that's a really big number, 6.6 times 10 to the 19th molecules of CO2. Let's do a different version of this, just slightly modified. All right, so you might notice the exact same question. 4.82 milligrams of CO2 to, how did it change this time? Atoms of oxygen. So let me just say the first part of this problem is going to be just the same as what we just did. And I'm actually going to do it up here. 4.82 milligrams of CO2, 1,000 milligrams in a gram, and 44.01 grams of CO2 and 6.02 times 10 to the 23rd molecules of CO2. So this is just where we left off in the last problem. My question is, do we answer the question? Well, molecules of CO2 is different than atoms of oxygen. And if I take the math out of this and I just say, hey, I give you a CO2. How many oxygens are here? You're going to tell me what? 2. You might say there's 2 atoms of oxygen in every 1 molecule of CO2. You'd be absolutely correct. So now we can just multiply this through and it becomes 2 times whatever our last answer was, or in this case 1.32 times 10 to the 20th atoms of oxygen. Now if they had asked for total atoms, you would have put 3 here, right? Because there's 1 carbon and 2 oxygens for a total of 3. If they had put atoms of carbon, it'd be the same answer, right? Because there's 1 carbon per CO2. So there's a couple different variations on the same scheme. One more, just I saved the most common for last, and it should be pretty straightforward. So same idea. Convert 8.73 grams of silver to moles. First thing you need to know is that silver is Ag. So that is important. Second thing you need to do is go to the periodic table and find the bigger number. And you might find something like this, 107.8682. And I might even say, what? What is that? Well, of course, that's grams of silver per mole of silver, or per 6 times 10 to the 23rd atoms of silver. But we're going to use the grams and the moles here. So, as always, start at the end. How many moles of silver do I have? Well, we're only given one number, so we better start with that. And as always, we have grams here, that's mass. We have moles here, that's amount. Do we have something that relates mass to amount to mass? And by now, hopefully this is getting redundant and easy. And you're like, yeah, I know this one. It's the formula weight, it's the molar mass. We already got it right there. And you are absolutely correct, so let's just jump in. Grams is on top, so you're probably also hopefully getting very comfortable at just translating those down. Moles on top. And hopefully some of you paused this and solved the problem before I did, just to make sure you can do it on your own. And my little cheat sheet says, when I plugged this through my calculator a second ago, that I get 81 millimoles of silver, 4.0809 moles of silver. So, hopefully this is enough to get you comfortable doing these calculations. Like I said, anytime we weigh anything in the lab, you're going to take that mass in the lab and do this to it so that you can compare it to other chemicals. That's going to be the first step in all your practical problems. Thank you for your time and energy. Hopefully you're having a wonderful day, and thanks.